Today, I would like to introduce you a paper from the magazine Mutilmodal Transportation. It's called Accessibility-Based Vulnerability Analysis of Multimodal Transportation Networks with Weibit Choice Models, whose author is Yu Gu, Anthony Chen, Songyot Kitthamkesorn. I hope you can learn something. This study proposes utility-based accessibility measures and a weibit-based analysis method for analyzing multimodal transportation network vulnerability to account for the multidimensional travel choice behavior in multimodal transportation networks. An advanced weibit-based combined modal split and tracee assignment model is adopted to derive the accessibility measures based on the weibit-expected travel disutility from both route choice and mode choice dimensions. The accessibility at the modal split level is derived from the nested weibit model, while that at the route choice level is obtained based on the path size weibit model. The proposed weibit-based vulnerability measures are inherently suitable for assessing the relative degradation in network performance and can measure the vulnerability of networks with heterogeneous scales without overestimating the importance of modes or routes sharing similar features. Using a simplified multimodal transportation network of Hong Kong, numerical experiments are conducted to demonstrate the properties of the proposed multimodal vulnerability analysis. The results indicate that the proposed analysis can effectively address similarity and heterogeneity issues in the analysis of choice behavior and network vulnerability, which are often ignored by the traditional logit-based measures. In multimodal transportation networks, travelers need to choose their travel mode and route together. To consider the combined travel choice behavior, this study adopts a hierarchical weibit-based choice structure as shown in Figure 1, to consistently model the multidimensional travel choices. Specifically, the NW model and the path size weibit model are used to model the two travel choice dimensions. At the mode choice dimension, travelers first decide on the type of transport service, private vehicles or public services, then select a mode belonging to the selected service type. The NL model, which addresses the mode similarity issue by considering modes belonging to the same service type in the same nest, is an appropriate approach to investigate such mode choice behavior, and has been widely applied to the mode choice problem. In this study, the nested structure of the widely used NL model is adopted for the weibit case. The NW model further relaxes the identically distributed assumption and allows mode-specific perception variances and heterogeneous sensitivity among modes belonging to the same service. The effect of relaxing both IID assumptions on vulnerability analysis is demonstrated in Figure 2 by comparing the NL model and the NW model in the context of mode choice. In the trimodal network shown in Figure 2a, the disruption is assumed to cause an increase in the travel costs of transit modes, as can be seen from the left panel of Figure 2b. The NW model further considers the mode heterogeneity and allows the sensitivity to service quality to vary even among modes belonging to the same service type. Due to the unadjusted conditional mode choice probability, the NL model tends to underestimate the change in accessibility of the previously inferior mode, and thus overestimate vulnerability at both the OD and the service level. Numerical experiments are conducted to illustrate the properties of the proposed vulnerability measure, an analysis method on a multimodal transportation network extracted from that of Hong Kong. The first section assesses the network vulnerability at each spatial level in disruption scenario S1, which is likely to take place when the travel speeds of all modes are decreased because of a speed limit or extreme weather. A higher value indicates a greater relative increase in the post-disruption travel disutility, namely, a higher vulnerability. Secondly, to show the effect of considering both mode and route choices in the vulnerability analysis, this section compares the vulnerability assessment outcomes from the proposed NW-PSW STA model and the PSW tracee assignment model in Scenario 2. The closure of link 8 influences the car and bus modes between OD pairs TK and YK. The third section assesses the weibit-based measures under disruption scenarios S2 and S3 to demonstrate the importance of considering the similarity issue at mode and route choice dimensions in vulnerability analyses. The fourth section further illustrates the advantages of the proposed weibit-based vulnerability analysis via the comparison with the vulnerability analyses based on other random utility models and other types of accessibility measures. Fifthly, based on the numerical experiments in different disruption scenarios using different vulnerability measures and analysis methods, several findings can be concluded. Firstly, comparing to the other types of accessibility-based vulnerability measures, the utility-based measures derived based on the random utility theory is advantageous in interpreting travel choice behavior in vulnerability analysis. Secondly, comparing to the traditional utility-based measure derived from the logit model, the study shows that the proposed measure performs better, especially at the higher spatial level, in the disruption scenarios, where all travel alternatives have a uniform increase in travel time. Thirdly, the proposed vulnerability analysis method based on the advanced weibit-based CMSTA model is shown to outperform the TRC assignment model. Fourthly, handling both heterogeneity and similarity issues at each choice dimension plays a critical role in the vulnerability analysis. This study proposes a weibit-based multimodal transportation network vulnerability analysis and measures to assess vulnerability based on the relative increase in weibit-expected travel disutility at different spatial levels. The weibit-based vulnerability measures are inherently suitable for the assessment of the relative degradation in network performance, which cannot always be fully captured by the traditional logit-based measures. The properties and advantages of the proposed vulnerability analysis and measures are verified in numerical experiments based on a simply at Hong Kong multimodal transportation network. The results further illustrate the superiority of the proposed utility-based measure to other types of accessibility measures, as it can comprehensively reflect the travel disutility from a variety of both used and unused travel alternatives provided by the multimodal transportation system. On the basis of the proposed network vulnerability analysis method and measures, there are several potential directions for future studies. 1. Develop a hybrid logit-based and weibit-based vulnerability analysis for consideration of both relative and absolute degradation. 2. Consider more choice dimensions to avoid the overestimation of vulnerability, and so on. 3. Derive an accessibility-based vulnerability measure that considers the features of emerging technologies. 4. Develop a probabilistic vulnerability analysis method to further consider the occurrence probability of disruptions and the uncertain variation in post-disruption performance.